Yeah, welcome to our session on software ecosystems. My name is Sebastian Baltes. I'm at SAP and the University of Adelaide. We have some great papers coming ahead, but before we start, we are still missing two presenters. One is the open source software onboarding talk. We now have the slides, but no presenter. That's not so good. And license rec. Yeah. Okay, and your slides are now just there, so that's also good. And for license rec recommendation. Okay, we offer that. Good. Then we have all speakers here, all slides. Great. So then, let's start with the first talk. We're going to hear from you. Can you quickly tell me your name? I forgot to note it down.
Yeah, it's okay. Justina, you just call me Justina.
Okay. Then Justina will present her work on an empirical study of Debian and Fedora practices. Looking forward to it. Please go ahead.
Yeah. Hi, everyone. My name is Justina. I'm final year PhD student at Queen's University, Canada. I'm going to present upstream bug management in Linux distribution. Open source software dominates the world because 70% of businesses are using open source software, but this doesn't come without any cost. Open source software has an average of 20 bugs per 1,000 lines of code, and it takes developers between 0.5 to up to 2 days to fix a bug. So we could estimate the cost of in a software project based on the lines of code and the fixing time and developer salary. So for example, the Qt framework library project contains 3 million lines of code. And the estimated cost of this project in 10 years would be around $2,000 US. And one expects that the majority of the bug would be fixed by the open source community, and only like 1% of the bug would need to be fixed. So the cost would be like $20 US per year. And this is the cost for only one project. So when it comes to several projects, then the cost would be way higher. So we studied the Linux distribution that contains of tens of thousands of open source projects. And in this talk, we refer that to Upstream project. So the distribution package these upstream projects into their distribution and customize and redistribute that to end users. As bugs in an upstream project is inevitable, so does that in an upstream package. And in such case, the distribution either wait for a fix from the upstream project, or they produce their local patches to fix that problem. But in this case, which means the distribution need to maintain the subsequent, maintain the fix to be compatible with the subsequent upstream release project. So in this work, we study how upstream bugs were managed by the distribution. So this is the research questions with what the percentage of bugs are fixed by upstream versus locally, and the time and cost of fixing this upstream bug locally, and also which bugs are more likely to be fixed upstream. So we extract more than 84,000 of high severity bugs across Debian and Fedora, and as we could see from the table, majority of the bugs actually located in the upstream packages, which is 86 and 76%. And the minority is in the in-house packages that are developed by the distribution developer. So in terms of the percentage of the bugs are fixed by upstream versus locally, while 60% of the bugs is fixed, surprisingly, we observed that at least for 73% of them, the origin of the fix is unknown. And 40% of the upstream bugs, only 40% of upstream bugs are officially fixed by upstream developers. And the percentage of upstream fixed versus locally is similar, which is 14 versus 13, and 5 versus 4 in Debian and Fedora, respectively. And in terms of time and cost, in Debian, locally fixed upstream bugs make user wait for 39% less time than fixed by upstream, but 50% more time than locally fixed in-house bugs. While in Fedora, locally fixed bugs make user wait more time than both upstream fixed and locally fixed in-house bugs. And the distribution need to maintain a median of 2 local patches per upstream package per distribution release. And they need to maintain that for a median of 1 and 2 distribution releases in Debian and Fedora, respectively. So in just summary, like the majority of bugs are located in upstream package, and the percentage of upstream bug fixed by upstream versus locally is similar. So it's not as small as we expect, like I mentioned at the beginning, like 1%. And the distribution need to maintain a median of 2 local patches per package per distribution release for at least 1.5 years. And the third is about which bugs are more likely to be fixed upstream. And we extract 27 features in 6 dimensions and to understand the likelihood of bugs being fixed by upstream. And due to the current constraint, the result is in the paper. I'm not represent that. So in summary, we studied how multiple open source projects are managed in Linux distribution. And we observed that up to 40% of the bugs are known to be fixed by the upstream developer, which is quite small. And the distribution need to maintain a median of 2 local patches per package per distribution release. And we use 27 features to know the likelihood of the bugs being fixed by upstream. Thank you for your attention.
Thank you very much. Right on time. Do we have questions? The audience. So if not, then I have a question. Did you reach out to the communities and like just communicated your results and got feedback from the corresponding developers?
Yeah, we reached out to the Debian and also Fedora developers about this kind of situation. And because Debian and Fedora actually follow in different practices, for example, Fedora actually just have a restrict policy followed by the Red Hat, which is always submit the bug to the upstream. But Debian is more like community-oriented Linux distribution, so they kind of have these different things, and they explain more a lot, and we describe that in the paper.
That's good.
Yeah.
And in the meantime, if there's no other question, how much of your results would you think can be transferred to like other projects, other ecosystems? Because the Linux ecosystem is, of course, a bit special compared to other open source projects. Is there any generic message that you could give to project maintainers?
In terms of generalization, because I think we just able to generalize that in Linux distribution, this domain, and specific to this kind of not rapid release, because there are different kind of release model, and Debian and Fedora are also the root of the distribution family. Like for example, the result cannot be generalized to Ubuntu, because Ubuntu is kind of rely on Debian, so they kind of have other factors to impact this. So it's more complicated. Actually, I have another work like that.
Sounds good. Okay, then it's time for another round of applause. And the next speaker, please come on. So, and while you are setting it up, let's make the introduction. The next talk will be about treating societally impactful scientific insights as open source artifacts, given by Cynthia.
All right, thank you for having me here. This is an opinion piece I wrote together with my PhD candidate, Demetriou, for the Software and Society track. So we wanted to spark a discussion in this community. Now, I'm a little bit of an outsider to this community, and I have 5 minutes and I'm Dutch, so apologies for maybe being a little bit not nuanced. I think we should question whether this concept of papers at competitive large venues still work. And I've been sharpening this, actually listening these last few days also to the discussions at this conference. We see some concerns about what we consider the output of academia, papers, especially on their quality control. More and more papers get submitted, reviewers get overwhelmed. Getting accepted or rejected then becomes increasingly noisy. Software engineering is scaling. I've been also in applied machine learning. It's even worse in there. Authors start worrying then about getting in, and then selling the story maybe becomes more important than the collective learning that we're seeing. And we can't reasonably keep up with what's going on in the state of the art. I've heard that complaint also a lot here now, in terms of people saying they've heard so many talks and didn't really know what was going on there. So I think we need to discuss that. We also see beyond that. Andrew, my co-author, he came from social psychology. He went to us because he saw a replication crisis in his field. And there was very little self-correction in there until huge scandals came out. Also, generally, working between disciplines, we've seen that interdisciplinary work is poorly understood and even worse, reviewed. If you have this whole unit of a paper, and there is psychology, machine learning, and new statistics in there, typically your 3 reviewers won't be that well prepared for all those 3 aspects to review that in depth at the level you'd ideally want. Furthermore, as Gil Murphy also said yesterday, we do see a lot of wicked problems and societal challenges emerging that now have a computational or a data component in them. That needs for people like us to connect to that from different disciplinary perspectives, connecting to policymakers. Now, the issue is, if we keep fighting about who is best and delegitimize everything that was before us, we don't seem to be very much on the same page. We seem uncertain, and that's not good for how science looks. And we've seen it happening before with big tobacco, with big oil. We've seen it happening with COVID policy. And now we have climate as one of the other concerns. So I do think we need to worry about that too. Now, Andrew has been quite activist in trying to think of other ways to get academic output out. Now, he's a PhD student, so again, it's been very tricky on his end. I have tenure, so hopefully I can think along on this. And what we were thinking was, what if we consider the development of scientific insight more like the development of open source software? So not targeting a paper, but seeing scientific insight as a continuously developing artifact of knowledge. From that perspective, if we write software, if you write software, I'm not even a software engineer myself, if you look at how you use Git to organize how you build the artifact that you're not completely sure about, isn't that the same for knowledge? Don't we have kind of our state-of-the-art knowledge as more or less a main branch? Can people not work together then on that in different branches while we still have that main branch on this is what we know now, where everything else develops? Maybe we fork off at some point. And also there will be naturally then inclusive credit of who did what, even if you're not anymore on main branch, with provenance to it. Also, no sane software engineer would ever send a complete application out for review. You would do pull requests that are dedicated, that ask for particular knowledge. Why don't we do that on our papers? So shouldn't we decompose our insight also into more maintainable and overseeable units? Where also relating to what Gil said about salami slicing, maybe actually smaller, better defined, more solidly reviewed units could be remixed into more things in a paper or a bigger complex system. And finally, what I very much appreciated moving a bit from machine learning to this field, computer science, software engineering does have organizational safety to find weaknesses. You like finding bugs and fixing that. You're not afraid that if you find a bug, your whole application needs to be retracted. We are very different regarding papers on this. So I also want to raise that. So we were thinking of this and submitted this as a paper to a prestigious conference. Why did we do that? Because we do feel this community may hold some keys. You've been researching this, at least when it was about software. You've been progressive regarding open science. There is the Rose Festival, there is pre-registration in some of your tracks. You seem about to reform, if I listen to your town hall, and willing to connect to the world outside of your own academic bubble. This is a more diverse conference in terms of disciplines than what I've been used to. So here, in terms of software engineers wishing to have impact, I also want to point out I see junior people being really enthusiastic about these ideas. Our students, our PhDs. Maybe this might be a reason for this particular community to prototype that. And for the seniors who've been saying, that's nice, but we cannot change the system, well, there are a lot of international initiatives actually aiming at doing that. So I just want to say it is possible. That's all I wanted to say. Slide and paper are up there, and happy to take any comments or questions.
Thank you very much. Can the next speaker maybe already go and set up while we answer the questions? Are there questions?
Hello, Lavinia Paganini. So I just started my PhD like 3 weeks ago, and I'm looking through scientific software, and one of the papers that really stood out was thinking about open source and pull requests as scientific knowledge. So I wanted to ask you the perspective of how you see publish or perish ethos and how we can overcome that, especially for those who are faculty and need these papers as academic contributions.
Yes, so I might have to be behind the microphone if that's fine for you. Yeah, sorry.
You have 1 minute, yes.
Oh gosh, yes. So I think make sure, of course, that you're protected if you're junior. Make sure your faculty supports this. At the same time, convince faculty that they set the academic rules within their discipline. So how the system works, if ICSE decides that they value this more than they value papers, it's fine. Everyone will trust them. The astronomers tell us all the time as well in the juries. So there, I think the seniors should step up a bit more in organizing this, where the juniors should indicate they really would like to do this. And I do think Publish for Paris had its best times at the scale we're seeing now, and ChatGPT will anyway be better at it, right?
Good. I have another question, but I'll ask like later, so that we stay in time. And thank you very much again. Does it work?
I think so. Let's see.
So the next talk will be a longer one, so not as rushed, luckily.
Oh, there we go. Maybe. Right.
Mariam will talk about rules of engagement, why and how companies participate in open source software. Let's go ahead.
Let's go ahead. Perfect. Hi, everyone. This is Mariam Guizani. I'm a PhD candidate at Oregon State University, and today I'll be presenting our paper, Rules of Engagement, Why and How Companies Participate in Open Source. Now, this work is a collaboration between Oregon State University and Northern Arizona University. So let's jump right in. First off, over the last 20 years, the OSS ecosystem expanded far beyond the weekend warriors and a dedicated few to become a more of a hybrid ecosystem where different players of different capacities work together. Now, in the 2022 State of OSS survey, 77% of surveyed organizations said that they increased their use of open source over the last 12 months, making OSS fundamental to companies' operations. Now we're noticing that companies, big and small, are contributing back to different OSS projects. They're no longer just using open source, but they're actually contributing back. And some of the major companies are spearheading the development of state-of-the-art technology. And here we can think about Facebook with React, Google with Kubernetes, or Microsoft with TypeScript. And this attracts thousands of contributors, whether they be volunteer contributors or companies. Now, we've largely investigated the OSS ecosystem from an individual contributor's perspective. For instance, their motivation to contribute, the different challenges that they face, and we have little knowledge on why companies contribute to open source, and when they do, how do they contribute to open source? Now, without a clear understanding of why and how companies contribute to open source, we have an incomplete picture of the different open source players, and the effort to sustain open source is relying on our understanding of these dedicated few. Now, in this paper, we tackle just that. So we tackle these two main questions. First, we look at what motivates companies to contribute to open source, and then we look at how do these companies contribute to open source. Now, because of the nature of our questions, investigating why and how companies contribute to open source, we performed a semi-structured interviews. So we interviewed 20 people, 20 participants from 17 different companies. So we had 7 small companies, 1 medium company, and 9 large companies. For instance, we had employees from Google, Microsoft, Spotify, and Red Hat, just to name a few. And here, selection criteria is that we wanted our participants to either have a leadership position, for example, a CEO of a startup, or to be in a position that was tied to open source, for instance, an OSPO lead, an open source program office lead. Now, table 1 of the paper details our participant list with their different roles and the company size that they're in. Now, for data collection, we analyzed our data. Well, first we transcribed our interviews, and then we applied open coding with constant comparison to identify the different motivations and contributions that each participant reported. We then did actual coding to build relationships between the different codes and categories. Now, both these processes were highly iterative, and we did reach code saturation after interview number 13, where no new codes emerged. This process took 36 weeks, after which we performed member checking, so we went back to our participants to further validate our findings. Now, a little bit more details are in the paper for the method, and I'll switch back to the findings. So here we found 4 top-level motivation categories that drive companies to contribute to open source. So for instance, companies contribute to open source to follow their founder's vision, whether it be that their founders have a deep history with open source or the problem itself is very much an open source problem at its very essence. They also contribute to be reciprocal to an ecosystem that has already given so much that they've used quite a bit. And they also contribute to open source to further grow their reputation. And this higher level motivation is composed of 5 different ones. So 5 subcategories. The most prominent one was visibility. That was mentioned by 76% of the companies. They also contribute to attract talent and hire people that are familiar with their tech stack. Now, the next one is contributing to gain a business advantage, which is composed of 4 different subcategories here. So for instance, the most prevalent one is that the business depends on open source. So their products, their tools depend on open source projects, and they want these projects to stay healthy and alive and not become deprecated. It also brings closer channels, so they have this engineer-to-engineer communication from different companies, or they have their user feedback that is more readily. Another one is the co-petition motivation, which I'll go over in the next slide. Now, what is co-petition? Well, co-petition is the act of cooperation between competing companies. Now, here our participants defined it as collaborating with different companies to solve a common problem, share resources, build a better product, and have a bigger market share. Now, one of our participants beautifully made an analogy here that I'm just going to reuse as an explanation. So basically, these companies come together to build the engine of a car, so to do the hard work only once, and this helps reduce the workload for these companies. It also builds a higher quality product because they're bringing in different skills from different companies and solving a big problem together. Now, what they compete on is the periphery of this. For instance, the exterior design of a car, or the interior design of a car, or the dashboard features. So this is kind of the idea of co-petition. Now, I'll move on to a few insights about reputation overall as a higher category. Now here, reputation was one of those motivations where different sized companies found different meanings to it. For example, for smaller sized companies, reputation meant to them gaining users' trust. So their users, the people that are using their project, and also being in the same space as all these big name companies and being associated with them. Now, for larger companies, it meant signaling good citizenship and being part of the open source community, and also gaining the community's trust by being a good open source citizen and contributing back to the community. Now, these different motivations, and we've seen a few of them, drive companies to contribute in multifaceted ways. In these contributions, they benefit different entities. So for instance, if we look at contributing tools and products, so companies are driven, for instance, by their founder's vision or gaining a business advantage or reputation. They can, for example, open source some of their tools and products. These could be frameworks or connectors or SDKs, etc. And this benefits the whole open source ecosystem by enriching it with active projects that are backed up by one or multiple companies. Now, when the question becomes how much adoption they can get with this open source product, companies sometimes would donate these projects to open source foundations to signal neutral governance and to signal that they are open to have contributors join in, whether they be companies or volunteer contributors. Now, to wrap up, with 97% of companies using and relying on open source, companies' well-being is very much tied to OSS's well-being. So we're seeing that the investment in open source is not just linked to a short-term profit, but rather an investment in the future. Now, our findings can help nudge companies to contribute to open source and be more systematic about their open source presence. It can help companies identify the motivations that are important to them and prioritize their contribution accordingly. It can also help OSS projects create an environment that attracts companies And open source projects can also reflect on the wide range of support that these companies can provide, and they can solicit the support that aligns with their project needs. Now, thank you very much, and I'll open it up for questions.
Thank you much. Any questions from you?
Hey, thanks for the fantastic talk. It looks like most of the things you're talking about are positive aspects of open source. So have you found any negative complaints about participating in open source projects from a company's point of view?
I think I'm trying to remember some of the points. One of the things that came out, because in this paper we also have a table that presents the different, kind of almost like best practices to be part of open source for companies. So one of the things that they mentioned is that companies tend to be afraid of, say, if an open source project is good and they could depend on it and use it, but if the environment of that project is a toxic environment, a non-welcoming environment, they will get away from it. But because one of the motivation is actually reputation, and that is just not a good place to be in. So this was something that was mentioned. Another thing that was mentioned is when companies contribute to open source, say they depend on a specific project and they highly depend on it, they tend to also want to be in a project where they can participate in the governance and they can have a bigger role as well. So having that, sometimes that neutral governance of a project, or seeing that if a project is has another company that participates and it's at the same level, is an important aspect of these contributions. I don't know if it answered your question, but these are a bit of maybe not negative aspects, but things that companies maybe tend to check first.
Yeah. Very useful insight. Thank you.
Do we have more questions there in the back?
Did you find any relation between the size of the company and the answers, or wasn't that possible with that amount of data?
Yes. Actually, the founder's vision, it was all about small companies. So all the small companies mentioned founder's vision as one of the motivators. Only one did not. So it tends to be more about startups, and the founders have a deep history with open source. So they start on open source. And that was one that was very much tied to smaller companies and startups. Also for the reputation part, it seemed that they had different definitions of reputation. So those smaller companies wanted to be part of open source to gain users' trust and also be in the same room as these large companies that are in open source. And on the other hand, larger companies were more interested in building trust with the community, showing that they're participating in open source, but they're putting the community first and not putting their needs first. So that aspect was more important, and to, after that, hopefully be part of the governance and be able to have a seat at the table as well.
Thank you. Any other questions?
Thank you very much for the talk. It's a really interesting topic. So a big problem, I was mentioning in the talk yesterday, Gail Murphy, that vulnerabilities in open source software and supply chains. So some companies would try to work with communities to try to improve that. Was that evident in any of what you saw?
Yes. So one of the main reasons of being part actually of open source as part of gaining that business advantage is because their product depends on those open source projects. They cannot afford not to be there and not to fix things or push their fixes as well, and make sure that that project doesn't get deprecated, stays healthy, has a healthy community. So that is definitely a big aspect of their motivation as well. Yeah.
Okay, then. No questions, and also we're running out of time, so thanks again. Another round of applause. The next talk will be about software bills of material, and Buming is going to present that.
Yeah, thanks for the introduction, Sebastian. So Good afternoon, everyone. My name is Bo-Ming Shan, and I'm a second-year PhD student from CSIRO's Data 61. And I'm going to present our paper titled Empirical Study on Software Biomaterials, Where We Stand and Road Ahead. So I will start by giving some very brief background introduction on software biomaterials, since I am not sure and everyone is familiar with the concept. So since the previous presenters has already given some background on the open source software and the prevalence of OSS in software, so I'm gonna begin with the growth of software supply chain attacks in the recent years, and these statistics from the Sonatype's State of Software Supply Chain report last year, and I think actually last month or recently they published a new report for the 2022, which I think there is again a rise of the software supply chain attacks. And during, for example, I have given the two examples of the infamous or famous software supply chain attacks, like the SolarWinds attack or the Log4j vulnerability, which is not really an attack, but yeah. And during such event, the lack of visibility into the software supply chain can pose considerable challenge for the company to conduct risk management, risk assessment, etc. So in such case, the I think if I remember correctly, I think during the October 2021, the White House actually issued a executive order kind of requiring all companies trading with the U.S. government agencies to provide these software biomaterials, which SBOM in short, to be handed to upon software delivery. And for the definition, an SBOM is kind of a formal machine-readable inventory of the components as well as their dependencies and relationships used for producing a software product. And here we kind of like extend this concept a bit to AI software because given the prevalence of AI and also our future, one of our future direction. And I won't talk too much about AI for now, AI bomb for now. So before I go to the next slide, I think for anyone like who's not so familiar with SBOM, I think quite intuitive analogy here is the ingredient list on the food packaging. Like it gives us, kind of tells us everything inside software or food, yeah. And about our methodology, I won't give too much details here, but yeah, you can go refer to our paper, which I'll attach a link or a QR code at the end. So basically, we conducted an interview with 17 SBOM practitioners worldwide, including, I attached a screenshot of the interviewee statistics here. And I think some of them are, if I remember correctly, some of them are actually from the US government agencies, like who has been kind of like provoking, kind of like advertising or promoting this SBOM from the very beginning, like from the NIST, NIST and NTIA. So I'll jump to the results and findings here. So I will first very quickly give an overview of the statement because basically we kind of like conducted an interview, and from the interview we conducted a series of coding similar to the last presenter, and then we extracted a total of 26 statements from the interviews, and we grouped them under 3 topics or themes. And then we kind of put these all these statements in an online survey, so we can have more practitioners or more participants to either support or refute these kind of statements to kind of like score them. And I attached the score here. So the higher the score, I think the more agreed upon regarding a statement. So I will jump into the results. Since we have like 10 findings here, so I don't think I have time to go through them one by one, but I will like go through maybe 2 of them like that I think may be more interesting. So, and I will maybe just go through the rest of them very quickly. So finding 1 is more general, like So it's about the benefits and also the lack of adoption on the and some issues regarding the SBOM adoption or application. So we find, so despite we identified the benefits brought by the SBOMs and application of SBOMs, we find there's a lack of systematic consumption scenario-driven design of SBOM feature. Because I remember from the interviews and also from the survey results, the participants basically they all agree like so currently the SBOM generation side, on the generation side, companies are doing this, but on consumption side, at least back then when I was doing the interview last year, the consumption is like very worrying. And finding two is about the also about the lack of adoption on SBOMs because for example the open source softwares, like I don't think like I think like many of them like don't have an SBOM, so yeah, that's a issue. And finding 3 and 4 are actually about the standardization or the data fields to be included in SBOMs, because finding 3 is actually about the finding 3 is actually about the generation of SBOMs. So they are currently, I think, after this paper publication, I think last month or last month, the NTI or NList, they actually published like a similar report. Maybe you can Google. Yeah, maybe I think it should be able to contain more information than our finding because it's more up to date. And finding 4 is actually about the standardization on SBOMs. Like, so I remember the U.S. government organization, they have this recommendation on the minimum data fields to be included in SBOM. But during our interview, we find that not every company is like sticking to the their recommendations. Like some companies are just doing their doing things like as according to their own needs, which is not a good sign. And finding 5 and 6 are relatively more interesting, and because during the interview, finding 5 is actually about the sharing. Like after the generation of SBOMs, how do the SBOM generators or how do the software vendors distribute the SBOM to their customers? Because they have these kind of like various concerns from the vendors, like they think some information is too sensitive to be distributed to everyone or to make public. So this is kind of about this, and we think maybe selective sharing or selective disclosure or content tailoring, these kind of access control can be applied to address this. And it's also our one of the research direction we are currently exploring. And finding 6 is actually about the verification and the validation of the SBOMs also after the generation, because during the interview, many of the interviewees told me like they were just generating the SBOM, and then if the customer asked for it, they will just give it to the customers. But there's like no, because this is quite new, so there was like back then there was like little verification or checking like integrity, this kind of integrity services during the distribution, so which is quite a problem. Because SBOMs can be tempered, like it's just some kind of file. And finding 7 is about the vulnerability and vulnerability and exploitability. I will not go into details about this one. And finding 8 is also about the tools, because we actually devised 2 research questions. The first research question is about the general status of the SBOM, and the second research question is about the tooling status of SBOMs. And we find there are many tools, especially the open source tools, but at least back then, I mean, because this research was conducted last year in June or July. So at least back then, the tools were very immature and lack support, not enterprise ready in general. And the last 2 findings are more general and just some findings about the standards and also some future calls for future research and attention. I'll just skip them considering the time strain. And lastly, Lastly, about the implications of this research, we kind of give a goal model for both industry and academia. And also, we kind of like identify AI bomb as a future direction, especially given the popularity of the large language models or something. And for industry, we give this recommendation, which on format extensions, which we kind of summarized or organized during the interviews. Yeah, I think that's all for my presentation today. And yeah, I attached a QR code if you are interested.
Thank you very much. Questions? Oh, multiple.
Thank you. Interesting. So you have used the term bills of material actually from systems engineering. But if you look at software engineering, if you, in product line engineering or product family engineering, we use the term core assets, where we also want to reuse the assets or the material. How do you see that? So what's the relation with bills of material and the core assets or reusable assets?
I'm not too familiar with these concept of these
product line engineering.
Yeah. But I think so. For biomaterials, they are kind of like an inventory list of all the like components and their relationships inside the software. It's like whether we're reusable or not. I'm not sure I'm answering the question properly.
Thank you.
Yeah.
You can always discuss later on.
Thank you for the presentation. And I have a question related to your experience and the interviews you had with developers, practitioners. And usually in the world of SBOM, you want a list of libraries, but you might not be using all the classes in the libraries or all the methods in the library. So do you think developers want a more fine-grained definition of SBOM? Do you think that is needed? What are your thoughts on that?
Yeah, I actually think so. I think this is more of a question that like the standards, the standards organizers or the maintainers, they should be focusing about. Because during the interview, I also asked one of the the policy driven. I asked him about her because about the standardization of the field, and he kind of recommends even for the different fields. The different companies really should be catering to their own needs to include apart from the very minimum requirements, which is I think stated in the list the official file. So and other things like the optional things, you can include them if you want, but it's not necessary or mandatory. So I think it's just depends on the communication between the vendor and the customer, what they can provide and what the customer want. Yeah, so it's kind of optional or not mandatory, but you can do it if you want. Yeah.
Thank you.
So we have time for one very, very quick question. There was one in the back. In the meantime, maybe the next presenter can just set up and.
I think my question is an extension of the last one, maybe. So there are different SBOM standards in Europe, and NTIA, I think, is in US, and ISO in Europe. You mentioned that, did you? I think that it's very difficult if there isn't one standard. So how do people deal with different standards for SBOMs?
Yeah, actually, this is quite an interesting topic. I think I also write this in the paper as a very interesting argument between different interviewees, because I think I interviewed some kind of SBOM 2 developer, and they kind of think they mentioned to me they think the standardization is a huge benefit of SBOM because the data inside the SBOM is already there visible without SBOM. It's the important things the standardization it provides, so it can be has the potential to provide a future ecosystem to be built upon. But they also mentioned to me because they are tooling tool developers, and for their tools they want to include more features, more support more functions, and they kind of think the current formats are limiting or restricting their development of the tools. So it's kind of interesting, yeah.
Okay. Thank you very much. Another round of applause, and then we are ready for Hao, who's going to talk about open source software onboarding as a university course. So please. please go ahead.
Thank you. Hello, everyone. Today, I'm very excited to share our experience of building and teaching an open source software onboarding course at Peking University. And we think our experience could be useful for many people, so we write this down as an experience report. And for this course, I am Haoxiang, and I serve as the TA. And I thank a lot to Professor Minghui Zhou for making this course possible and other contributors for their contributions to this course. And so why we need this course? First of all, we think the most important reason is that open source software is in great need of capable contributors. There may be many people who are willing to contribute to open source, but all these people need to know how to do many things, like how to communicate, how to overcome the technical barriers, how to make things work by themselves. And eventually, there's only a few people who are able to become successful open source contributors. And there's some sort of a contributor shortage, as indicated by recent reports and by other open source contributors. And we think that we observe that this is also the case for many computer science students at our university. They are willing to contribute to open source, but don't know how to. And that's why we are thinking about opening a new course to make the situation better. Unfortunately, there is a gap between software engineering courses in our university and open source software development. Like in a typical software engineering course, students may learn various topics and implement some non-trivial piece of software in teams, like with each other. But in fact, the open source software development is almost in a quite different scenario, and students need to learn more things to be able to actually do things in open source software. For example, a student may need some specific motivation of doing something. They need to learn from a large number of documentation and a very huge code base. They need to interact with the community and adapt to the unique culture of that community. And they need to make small contributions and work with they need to make small contributions on a large code base and work with remote open source collaborators. We think the process is so different that students will need some sort of a semester-long devotion to actually get used to it and master it. That's why we are considering opening a new course for that. And here we give some examples of if students do not know how to do everything in the first place, it's common for them to quickly fail, and we have two examples. The first example is that we found that many students do not even try because they are scared by the huge amount of documentation, the huge amount of code base, and they just be scared of everything and do not actually do anything in open source software, even if they want to do. And for some other more extrovert type of students, they may have an idea of doing something, but if they do not know how to communicate, how to know the way the open source software community will expect them to behave, they may just quickly fail, and in all cases, the experience will be discouraged if they do not know how to do it. So, in this course, we hope to make students understand the nature of open source software development and make them know how to contribute when they want to, whatever career path they are in the future. And I think there's also a very interesting thing. We hope them to do something really interesting and get some real-world coding experience throughout the whole course. So for this purpose, we have designed the course with all kinds of lectures like open source software fundamentals, open source software technologies, and we also invited real open source software developers to introduce their projects. We also include some advanced topics. And we have designed 5 different assignments to cover the use of version control systems, evaluating projects and tasks, CI/CD, dependency management, etc. And since time is very limited, we have a course website here. Unfortunately, it's in Chinese due to some restrictions. And but feel free to take a look at it. Use Google Translator to go over the materials. And I think the most important component in our course, and what we have also learned most, is the course project, in which we intend to let students make actual and significant contributions to an open source project. And we want this experience to be as flexible as possible, so we offer 2 options in the first year of our course. The first option is to contribute to one of the selected projects, in which we invite a mentor from that project, and they give talks in our course and tell students what they can do. And if students choose to make contributions, they can have personal reach with the mentor. The mentor can tell specific development tasks for them to do. But if students do not want to contribute to our selected projects, they can contribute to any of the open source projects that they think they are interested. However, in this case, they cannot have a specific mentor from our course. They need to interact with the community and find resources on their own. But in both cases, we have a set of interventions from the professor and TA, like we ask them to do certain assignments related to their contribution, and then we ask them to do 3 presentations and the final report. And we have much more detail in the paper. If you're interested, please refer to that. And the course was first opened on 4/2021 with 16 students. Among them, 5 choose the first option. All of them contribute to the Paddle project, which is an AI framework just like PyTorch and TensorFlow. And the remaining 11 students contribute to all kinds of open source projects in a wide range of application domains. And in the remainder of this presentation, I will describe the most interesting observations we have from these students and the lessons we have learned. So the first observation is that for project and task selection, we find that students actually can follow our instructions well, and they choose open source projects they are really interested in. They are able to find projects with a good community, and they are able to find tasks they are really interested in or willing to improve. However, even with all the interventions, and even if they can eventually find something to do, the process is very difficult for students in choosing the second option. They may, after some exploration, find that the project is not actively replying to them, or they do not have the ability to work on the project because it is too difficult, or they lack the necessary environment to do actual development. And there's also many communication barriers, which is well documented in the existing literature of software engineering, but they can apply certain strategies to overcome them. For example, if they get criticism, which is quite common in open source software, we tell them to do not get discouraged, which is pretty common for newcomers, and for them to learn and to revise and to defend their own work if necessary. And we have a few successful cases that are documented in the paper, and if you're interested, please refer to that. And eventually, all students successfully make open source software contributions, which from our perspective is a very impressive achievement. And the type and the amount of contribution differ for students choosing different open source software projects. If they choose to contribute to Paddle with a mentor, they are able to implement larger features and some significant bug fixes because there's a mentor who can tell them what to do. However, if they choose to contribute to any software project they're interested in, they need to spend a lot of time to overcome the 0 to 1 procedure. So they need to spend a lot of time to learn and eventually do small bug fixes or documentation improvements. And only some of those with better experience can contribute larger bug fixes and feature implementations. However, perhaps I think the most rewarding feedback we receive is that all students have found open source software contribution a very positive experience, regardless of which option they choose. They say that they feel a strong sense of achievement when making contributions that actually help others, and they find that in general, open source software communities is very friendly and positive, which is very different from some online communities. And another very interesting observation we have is that students tell us that they have actually learned from overcoming the onboarding barriers. So, okay, I'll be faster. So throughout the whole process, they report that someone somehow learned how to be a software professional, how to write robust code, etc. And finally, a very interesting observation we have is that only students who find projects on their own retain in the open source software projects. However, for the 5 students who choose to be mentored, none of them, we observe that none has further contributions after the course to Paddle. However, for the 11 students who choose software projects on their own, there are 4 of them who have further contributions after the course. And to summarize, the 2 groups of students have significantly different onboarding trajectories. For students choose to be mentored and choose to contribute to one of the selected open source projects, they can have fewer project and task selection barriers, fewer communication barriers, and they are able to make more contributions and report a very positive experience, but none of them retained in the open source project. However, for students who choose open source projects on their own, they have more project and task selection barriers, more communication barriers. They have made less contributions, but more often retained in open source projects. Although they also report positive experience, the experience is quite different from students choosing the first option, because it is like a very unique 0 to 1 experience, which is more like actual open source software development. And finally, through our teaching experience, we have learned many useful lessons. It's really hard to summarize everything in one page, so I will go over this quite quickly. The first lesson is that we find open source projects are a good ground for learning real-world coding. However, and we find that students should find projects based on their own personal interests. And we find that even if mentoring is very effective for making contributions, if we have excessive mentoring, it will be like it will more like outsourcing, and will make the whole project, the whole contribution experience deviate from actual open source software onboarding. So that's why we are thinking whether to remove the first option and in the future courses, and to like make every student choose projects on their own and explore on their own. And for the retention, we find that intrinsic motivation matters, but like how to cultivate them is a very open problem. We are planning to explore how to do this in the future. And to summarize, we have presented an open source software onboarding course and the outcomes of this course in the first year. And if you are interested, we have a paper QR code here and the course repository QR code here. And you can ask any question to me, and perhaps more importantly to Professor Minghui Zhou, because she's the one who will be opening future courses. And yeah, that's all. Thank you.
Yeah, thanks. Questions? We have time for one. Oh, 2 questions.
Hi, thank you for the talk, really interesting topic. And I'm very curious about the choice between option 1 and 2, and the fact that a lot more people chose option 2. So I was wondering, well, one, if you knew anything about their motivation, were they really interested in a specific topic? And also the gender distribution, if you have that information between the 2 groups and who chose what.
I think the main reason for many people choosing the second option is that they may not have the sufficient expertise to contribute to the projects in the first option, especially for those related to cloud computing and database and operating systems, which is significantly more difficult, even if they are in desperate need of newcomers. But they just, or frankly speaking, they just want to do something. They feel that it is easier, and for their geographic distributions, we have some very not well supported observations that we observe that students choosing the second option are more generally strongly motivated. They may have a strong motivation of doing something, but for the first option, there may be some students who are just willing to like get a good score from the course. Okay,
thank you very much. Unfortunately, there was another question, but unfortunately, we're running out of time, so maybe you can discuss that later on. Okay, another round of applause, and then the next speaker can come up. We will now hear about an empirical study of license conflicts in free and open source software.
Hello, everyone. I'm Cynthia, an engineer from Institute of Software, Chinese Academy of Sciences. In this talk, I will introduce our work, an empirical study of license conflict in free and open source software. It's a joint work with Professor Jinzhong Wu, Professor Yanjun Wu, Xu Wang, Tianyue Luo, Sheng Qu, Ling Xiang, and me from Institute of Software, Chinese Academy of Sciences, and Mu Tianyang from Beijing Zhongke Weilan Technology Limited Corporation. This talk will be divided into the following 4 parts: background, design of deck, evaluation, and conclusion. So let's start the background. First is a key catalyst in the software development, spurring innovation and technology advances. its benefits have expanded beyond the open source community into academia and commerce. FOSS impact on commercial production is notable for enhancing efficiency and cutting costs. However, FOSS also presents challenges, particularly licensing issues. Open source code, while generally free, comes with license outlying terms that can be complex and hard to grasp. Non-compliance can be lead to license conflict with serious implications. Now there are some studies on license analysis, such as FOSSology, Inca, FOSS-LTE, and other tools. Most of the existing tools focus on license detection or license semantic analysis. To tackle the above problems, we propose a tool named DAC. Here is the overall framework of DAC. DAC is capable of scanning open source license for software in all programming languages. By matching the scan result with the license knowledgeable base, it detects a conflict in the use of open source licenses. Furthermore, DAC provides two ways to resolve the conflict: code replacement and license replacement. In DAC, we build a term extraction model based on the label-specific attention network, inspired by multi-label text classification, and use the semantic information of labels to determine the semantic linkage between the terms and the licenses. We output the scanning result of licenses in a tree structure and to obtain the distribution for each license in the software and to locate the positions where the license appear. DAC matches the detection result with the license knowledgeable base, makes a conflict determination based on the calculation result, and designs code replacement and license replacement to resolve the license conflict. Next, I will talk about the details of each step. The license analyzer uses natural language processing to automate the analysis of the wide variety of software licenses, overcoming the limitations of manual analysis. It consists of two steps: license term extraction and term responsibility recognition, categorizing into 12 common terms found in licenses. Using the multiple classification and the label-specific attention network, each license text paragraph is classified into multiple categories. Furthermore, license analyzer output is the license terms and associated responsibilities by combining the result of the two classifications. Finally, we build a license knowledgeable base containing license terms and responsibility. The license sniffer of the DAC operates in 4 steps: file scanning, potential license detection, precise matching, and information flighting. It starts with transforming text into numerical sequences, then use the hash values and rule mapping to locate the licenses. Precise matches are made using the keyword vectors, and the results are merged and filtered to provide detailed license information. Solution engine resolves license conflicts by comparing responsibilities, and each term is process solutions like code replacement or license replacement based on the severity of the conflict and the criticality of the code. If the conflicting code is vital, it may be restructured or replaced if the non-critical deletion is considered. The evaluation of the stack is have 3 tests. This test including license terms extraction, terms responsibility recognition, and manual analysis. For license terms extraction, DAC achieves a macro F1 score of 0.816 on dataset of 3,256 in setting open source licenses. For terms responsibility recognition, DAC achieves an F1 score of 0.948 in the binary classification of terms responsibility. For manual analysis, the average number of terms analyzed by DAC is 201 with a 76.0% accuracy and 0.772 F1 score. While the above is overall content of our work, we designed the DAC to automate the extraction and responsibility assignment of 12 terms from open source licenses, significantly reducing the manual effort required in the license analysis. DAC analyzed 3,256 open source licenses to build a knowledgeable base, aiding in conflict detection and resolution across a broad range of licenses, unrestricted by the project programming languages. We analyzed 16,341 popular open source projects on GitHub using the 1,787 different licenses, and found that 27.2% had license conflict. This reflects the significant issue on the improper license usage in the large number of projects. That's all. Thank you.
Thank you very much. Questions? 2. We have time for both. So.
Thank you for your talk. I have a question. I'm wondering, some projects may have a large number of software dependencies. If you write Python code, you may pip install a large number of packages. Can the DAC consider all its software dependencies, during its license analysis?
Maybe it's the tendency for our future work. Thank you. Hello. Excuse me.
So license conflicts must be relevant, must be relative to a particular law. And so I wonder if, if it knows Chinese law or if it knows American law or European Union law. Does it matter? And how does the software tell?
Maybe add something.
Wait.
No, I want to add something. Maybe you can, into that direction, just clarify how the system determines which licenses are in conflict and whether that is relative to a country. I think that was the question. Legislation in a country.
For different countries, the DAC is maybe. This question, maybe we don't.
Yeah, sure. And if you want to discuss that later on in the coffee break, we are of course free to. We can take that offline and talk later on and just clarify the question. Okay, is there another question? If not, another one then.
Have you compared your tool with other existing commercial solutions, like those offered by White Source, or those previous publications in some 10 years old paper by German Depenta? And have you compared your work to existing work in commercial tools?
We compare other tools like this, the tools I prepared in the slide. No, just now. Such as Forceology and Ninka and license, such as these tools before.
Thank you. Maybe. Thank you.
Okay, then. Thank you very much. Another round of applause, and then the next author can come up. Huawei is going to talk about license rec, knowledge-based open source license recommendation for open source projects.
Hello, everyone. I'm Huawei Shi, first year PhD student. I'm going to talk about license rec, a knowledge-based open source license recommendation tool. This is a joint work of Xinwu Runzhi and Minghui Zhou. We all come from Peking University. Open source license dictates the terms for how open source software can be reused, modified, and redistributed, and provides a legal foundation for long-term development of open source software. However, choosing a suitable license for a project is not an easy task for developers. Selecting the right license can be confusing for developers, as there are numerous similar licenses with complex legal terms. There are already some tools to help developers choose a license. However, existing tools lack comprehensive consideration of the actual difficulties and needs of developers when selecting licenses. For example, the tool Choose an open source license designed by GitHub, only focused on a few basic recommendation scenarios. It recommends permissive license for developers who rely on community development and recommend the GPL for developers who prefer to share source code. However, the actual needs of developers vary substantially, and ignoring compatibility with licenses used by third-party components can lead to legal disputes. License rec is designed to provide developers with license recommendations that can consider both the compatibility with the license of existing components in the project and the complex requirements of the users. Our tool achieves this by building a knowledge base that contains license term features, compatibility matrix, and the license selection guideline. Using the information in the knowledge base, our tool completes processes such as compatibility checking and user preference characterization. Next, I will provide an overview of the recommendation process using our tool. If you want to select a license for your project, you can upload your project. If your project is a new one without any code, you can skip this step. License rec will employ scan code to scan the entire project to obtain the existing component level licenses in the project. In addition, license rec supports dependency analysis for the three most widely used programming languages, Java, JavaScript, and Python, and retrieves their license from the libraries I/O. After obtaining all license information for dependencies and components, this step will involve compatibility checks on existing license in the project. Open source license compatibility refers to the feasibility of distributing derivative works under a different license from the one used by modified or combined works. This step will filter out licenses from the recommendation pool that do not meet the compatibility. Next, license rec will further narrow down the recommendation pool based on user preference. By asking a series of questions, license rec can characterize their preference and determine which license type is best suited for their needs. License rec determines the final recommended licenses that match the preference. Finally, license rec displays the terms of each license to help users understand their differences and make a final decision. In addition to offering web-based service through our website, licenserec.com, we have also released a Ruby package and integrated it with the open source platform GitLink. That's all. Thank you.
Thank you very much. Questions? If not, there.
Thank you. Very interesting demonstration. Do you plan any validation, for example, on how this actually influences choosing a license, or whether it promotes several licenses more strongly due to their nature?
Sorry, can you repeat again?
Do you plan any validation on the impact of your prototype?
We did a user study. We invite 10 developers to use our tools, and they all gave a positive feedback to the tool.
Okay, thank you.
Thank you.
Okay, thanks. Other questions? Then I have one, and then Fabio can go up. A bit early in schedule now. Have you considered extending the work towards that you can recommend people, if you get rid of this dependency, then you can also use that license? Like not only based on scanning the repository and then saying these are possible, making these trade-offs and saying, okay, you only have one LGPL dependency. If you get rid of that, then you are more flexible in terms of licenses. Have you considered that as a potential next step?
We recommend licenses consider both the compatibility with the dependencies and their preference. So,
but they can really in the tool only change basically their preference. They cannot say, okay, if we ignore this dependency, then something else comes up. Okay.
No,
that was the question. Okay. Good. Any other questions? If not, thanks again. And thanks for everybody who stayed until the bitter end.
Yes.
No, not that Fabio is the bitter end. Fabio is going to talk about, will you come back to contribute, investigating the inactivity of open source core developers in GitHub?
Okay. Thank you. So thank you for staying until the bitter end then. I will skip any introduction since I don't have much time. I will jump right in. Motivating why we did our study. So there's a good amount of evidence that says that when core developers disengage from open source software project, they disrupt the productivity of the project, or they can even cause the death of the project themselves. But relatively speaking, research has focused most when investigating the developers' life cycle on studying how people join projects, how to keep them retained and make them long-term contributors. And when it comes to studying instead disengagement, few studies have studied that, focusing on the factors related to abandonment using mostly survival analysis. So we thought there is a space to investigate the reasons why developers disengage, to model the transition from being active to completely disengaged. There must be some stages that they go through, the breaks that they take before they completely disengage. Also taking into account that developers must contribute to a project having some sort of unique rhythm of contributions in their history of contribution. So we devised a research framework in two phases. We started with a couple of rounds of interviews of open source software project core developers, and came up with a model that would model exactly, sorry for repetition, but the state and transition of disengagement. And then we defined a break identification algorithm where we implemented this model and tested on trace data collected from 18 projects from GitHub. and applied trying to mine the state and transition for over 500 core developers project. By core developers, I mean developers that altogether author 80% of the source code basis. And a subset of these developers, 17 track factor developers, actually, we conducted a survey with them to see if they would agree with what those states and transition that were identified by algorithms. So in the end, we answered 4 research questions to understand whether our method was able to identify breaks correctly, how often developers take break and how long these breaks last, and how common the transition between states are. And here I will focus on the first and the last one. Please refer to the paper for further details. So this is the 2 models that were iteratively developed. We started on the left using a circadian metaphor, but the survey developers didn't really like the metaphors. They didn't like the name sleeping and dead were kind of so like negative, like dead, you don't come back from the dead, right? And so and on the right-hand side is the model that we used where we actually used a more precisely state model where you see the activity that keep you in that state, and also acknowledge the fact that after some time interval you must transition to another state. So I just got the red card. I will move on. So data collection. We collected data from 18 projects, identified the core developers, and but when we analyzed their activity, we didn't do just that at the project level. We did it at organization level. So for all the core developers, we saw what they did in the entire GitHub organization. So for all the projects within the organizations. And to define the algorithm, we use, well, first we defined a break as the number of days in between consecutive commits. And to capture the fact that each developer must have their own rhythm, we use this approach based on outliers to identify the longer than usual breaks. So you see above there is the outer fence that will be a threshold. So the very large outliers for us will be what we will call a break. And instead of considering all the history of development together, we use a sliding window algorithm where we will consider a smaller chunk of the history, find the unusual longer than breaks within those windows, and then shift it forward by 1 week. We tested different values and found that 3 months was best. And then, of course, we labeled a state and transition. Please refer to the paper for the details. I don't have time right now. Findings. So of the 17 answers that we got, this revision was appreciated by developers. They agree with that. The disacknowledgement that you see on state and transition relates to the gone model, because they said that actually they didn't consider themselves gone, but actually our model could not capture their intentions. It was just that according to our model, they were inactive for 12 months or more. The change that we did is that we renamed non-coding to active non-coding, because they felt that you can be active even when you don't write code. Doing a pull request is also being active, so that was true. It was a misconception from our side in the beginning. And the reasons for taking breaks and coming back is what we call personal reasons, as compared to problems with the community, just to name one. And I will skip this, and then just for you see here on the right-hand side there are the probability of transition. I will just point to 2 interesting facts. The smaller project, we found no transition into the gone state. So the smaller the project is, core developers cannot afford to transition into gone state. Otherwise, the project will be bad. And the more active a developer is, the fewer the chances of disengaging completely. Exactly 61% decrease of the chances of disengaging completely. Sorry for being over time.
Thank you very much.
My very best.
Thanks. Questions? There's one.
Hello, is more a clarification question on how you identify the core developers?
So as I said before, first we consider 2 sets of core developers. The core developers in the sense of the authors. Oh, sorry.
Yeah, I think the slides are gone.
The slides are gone. First, two types of identification. The authors who
authored
the 80% of the code base, and for the track factor, we use a tool developed by Abelino and others. You probably know them. They identify track factor developers as really those that will then define as those who, if they left the project dies. Probably you're aware with the track factor developer metaphor. Okay, so these are the two ways that we identify core developers.
More questions? Then just one quick question in the end to conclude it. How often did you see the projects acknowledging that they are dead or inactive or whatever? Sometimes you see this like in the README file, this project is inactive.
There's a project that we didn't consider dead project, only active projects by definition. So I cannot answer that.
I see. Makes sense. Okay then, thank you very much.
Thank you.